Okay, welcome to Wickerson Studios again. This is Grasshopper for Rhino 3D ABC 123. So I'm going to be into the maths now. I'm sorry, I'm still wearing my param shirt. I thought I'd start with this captured image of what I've put into ArtStation. It's a little out of the norm, but it's been started since I started grasshoppering away from using Tinkercad. I definitely have some interest in these strange little worlds and these devices and robotics and kinetics and sound, along with this digital and analog prints that I've been working on internationally. Just thought I'd throw it out there for a point of interest. Anyhow, let's get started. Let's jump into a little more boring page. I'm not going to be using much geometries, plane and some points, but I'm going to be going into the math tabs pretty hard and fast right here. So that said, what I've done is listed uh, all of the nodes within the domain, all the way through to the utilities. On the left are the ones I use quite often, and the one on the right are the ones I use a little less so. Not really into the matrix tools, so I won't have much to say about those. The operators are pretty good to go through and apply. I'll do that with also the scripts as I move through the polynomials and scripts, looking at a few of these things. I think I lost one. There it is, down there, the VB script, but I'll probably go into Python script code, and then the trig functions, and into utilities. That said, I'm going to start with what I pulled out of the first section, and I pulled it out in groups, and that's what we're going to focus on. Right now I'm going to make this large screen so you can really get into it, and here we go. These are the nodes that I think are the most common and worth figuring out. What you basically got is a construct domain node. When you put that together, I have borrowed from the set section under sequence a series. I may borrow a series in sequence or range, but after the sequence set, I've grabbed the range so you could actually start to grab some data on this. A construct domain will develop by 0 to 1, but I set mine from, well, whatever. You can see the number sliders change. Right here, they're going to change from 0 to 10, depending on what I input as the beginning and end of that domain. Ranges are very essential, if you remember back to your early math, to come to dealing with domains. But I've also got an ability to move into the steps. And what I'm going to do here is just grab a number slider, double click, hit an integer. And let's say we had a few different steps. Let's say we were only taking 2 steps from 0 to 10. Well, obviously, we get 0, 5, and 10. If we were to slide that up and actually have 3, now we're looking at a range tool now, but it's definitely dependent on that domain. What I then do is you can take a look here. You can change this. Basically, there's a construct domain tool, so a deconstruct domain does the same thing. It pulls it right back out of the range and takes it right back down to what that actually is, from 0 to 6.988 at the moment. Another tool is the bounds. You're going to need that. I'm going to show you how to apply that with the remap. But the bounds is from 0 to it covers the same information coming out of the domain currently. Basically the range bounds of that. What I've got here now happening, and I'm going to shrink it a little bit, is I've got a consecutive domains, which is pretty cool, and you can make it additive or not, but otherwise it's just taking those numbers in the range in the steps. So if there's 3 steps between 0 to 10, you're going to basically have consecutive domains 0 to 3.333, then 3.333 through to 6.666, through 6.666 through to 10. And that's it. And so that's a good way of looking at deconstructing a domain, once again, but using it after consecutive domains. If you put this to true, which is a Boolean toggle, which we saw in the params, it's going to add those up, and it's actually going to go from 0 to 2. But you can see, sorry, it's going to go from 0 to 3, then it'll go from 3 to 10, and then it will go from 10 to 20. So it's adding those up consecutively, and I leave that off because there's no point doing that. I also have dividing the domain. If you take a look from that range, we can divide that domain right back down into segments, and we're going to be getting into that a little bit later, but you can see how many times you want to divide that. If you divided it by 4 segments, it's going to go from 0, considering your domain range starts at 0 and goes to 10. Well, then if we divide it into 4, we're going to get 0 to 2.5, 2.5 to 5, 5 to 7.7, 7.5, and so on. So those are some good nodes that you're going to have to need to know, and this is just getting into the data that's going to inspire your geometry and motivate that. Long before you get into surfaces and solids, even lines, we're going to be dealing with points and ranges of points and series of points. So it's a slow start, but the deeper you go into this, the smarter you'll be, the better your codes and script will be, and the better you'll understand it when you start getting into lists and getting into data trees. Good luck with that. We'll get there, but it is going to take some time, and it's going to take me some more time. Here's a great example of the remap tool. I have a Remap Plus plugin that I brought down that does this all within a cluster, which I talked about in the last video. We're already at 5 minutes, so you've got a domain. Instead of me just dragging this down from up here, I cut and pasted it. I have a range. So basically, I take the range value, which goes from 0 to 10. I take a source. The bounds, if you remember, will go from 0 to 10 as a range. And then what's nice here is I've got that range going to the value, that bounds going to the source, and then I can set another domain to remap that range of 0 to 10 to anything I want between 2, let's say between 4 and 36. Well, there's how it divides up. You're going to need to use this all the time when you get reparameterizing things in, and you'll be actually probably remapping everything to a reparameterized number system between 0 and 1. That's something that's going to come up common, but this is definitely one of the scripts you're going to want. You're going to want to cluster this, and I actually have it in my math tools up here as a Remap Plus I pulled from Parametric House 3, and that's actually a nice tool because it just grabs the data, you take your minimum, maximum, and boom, you're left with the output. So it's actually skips having to write all this, but if you double click on that, you can see basically that's what it was in the cluster. I talked about that last time. Let's save and close that, and let's just leave that down there so we remember what's going on with it. The next ones I want to show are pretty darn simple. Construct 2 domain, deconstruct domain 2. So basically, you've got a U value, min and max. You got a V value, min and max. It's going to give you that panel range of the 2D domain, and then you're going to take it apart. It's going to give you back those exact numbers that you put in. So if you change that to 4, it's going to change the 4 over here. Change that 10 back down to 6, say, or 8. It's going to change that to 8. Then once again, I've got construct domain, and then I'm constructing a domain 2 this way. It skips having to put in the U and V, but you end up having to put it into the domain anyhow. It does the exact same thing, and it goes, and then deconstructing domain 2 is going to give you the U and V component back out of it. We're almost done. We've got a bounds tool, which is pretty cool, and this is where I actually did a little bit of geometry. It's not too exciting, but let's say we grabbed set multiple points, and we grab around here. What it's going to do is build a domain around those points. Which had been set in here. I guess it would have been a little easier understandable if I went into params, grabbed some points, and let's say we went in here and we extracted that parameter instead of added one. There you get those points that are actually in there. There are the points, and there's your range. So just so you can make a bounds 2D from points if you feel like it. Surface is pretty cool. I took a surface over here. I will take that surface and hide it. We're now left with the Grasshopper ghosted image of that surface. And at that point, I've got a segment tool to divide domain 2, which I can divide it into many segments you want. And even though you don't see any geometries or lines coming into this, I'll have to set my previews differently. You can see that as I pull that surface out and put it into a domain 2 container, it has that domain 2. But if I pull it out after doing the segment split, you can think of it as kind of what Weaverbird mesh tools do, and that's a plugin we'll get into later as well. But basically now you can see I've got 4 domains running, and if I want to take that up to whatever, you have to imagine what's happening here. If I split it 10 by 10, we've got 100 of these running down, 100 little tiny cubes, and they're going the spans of what it would be related to the size of that original block. So I think that's it. So that's just getting over the first few tools in maths. That's going down the domain list, taking a look into them. I might have skipped a couple. So I skipped using Remap Plus. I talked about that. Find domain, you can do that. It's using a little bit more logic and includes these values in that domain. It's going to show you, and you can set your deviation on that. I don't use those. I guess I would one day if it came in handy. But what we've done is we've taken all this, we blocked them. I'm going to grab them. I'm going to put them in another group. I'm going to take that group and make that peaceful, comfortable blue. I always miss. There we go. And we're done with that. So what we're going to do is go into another video, and we're going to talk a little bit about what I can tell you about matrices. And I don't use them, so I don't have too much to say about them, but they definitely will come in handy as we get into more and more maths. Some interesting tools that happen. And then I'll get into taking a look at your scientific calculator for the rest of these things and really seeing how you can pull the maths. I think they've told me that you pretty much know 65–70% of everything you need to know about Grasshopper if you can get math sets and vectors into your brain, and then the rest of it is all just transformations of solids and surfaces and geometries. It's really, that's the logic behind it that I think is worth really exploring, and because of my history, that's where I want to go, and that's where I want to teach. Thanks for listening, and we'll just, for interest's sake, back out of here and give you a nice image of scrolling down some weird little rooms. Probably the most intricate code I ever did was I Python scripted this one. Wheelbarrow wagons self-generate from a Python script in the Grasshopper, and they actually were built within the Tinkercode program, which is online, free online. I thought that was kind of interesting to make that a whirlwind of glass wheelbarrows. So you got to be creative. You got to do things that maybe don't make a lot of sense to a lot of people, because who knows if you're speaking to the past or speaking to the future. Just get busy, have fun, enjoy life, and remember, life is way too beautiful.